Before we look at the video, I pulled out some stills and we can do a little orientation so that we know what we're looking at. In the video, the construction has been progressed to the point where we are now working below the existing subway structure. So the existing structure is completely supported on the temporary mini piles, and that's what's exhibited in this photo. Some of the elements here, these pipes in the foreground, are part of the dewatering system, and it's probably an ejector system because you can see an incoming line and a discharge line at each of the wells. These other vertical members are the mini piles or the drilled in piles which support the existing structure. What's important to note here is this very, very densely crowded scene. All this vertical members, they're all in the way of trying to get the new structural elements in place. And the white structural members here are the new framing for this underground mezzanine. If you can imagine the challenge, you're up in the street with a delivery of these long steel beams, and you have to lower them into place, rotate them horizontally, and somehow snake them through this forest of obstacles, and then raise them into place. The cut and cover system allows you to remove the concrete deck panels at any location so that you can bring the structural steel as close as possible to the point where it's actually required and then lower it into the hole. If you didn't have that flexibility of gaining access throughout the entire space, it might be infeasible to introduce the new structural members. So that's a critically important feature of the cut and cover process. In the next slide, you can get a good look at the horizontal beam which has been introduced through the invert of the existing subway structure. Getting that beam in place is a challenge. In this particular project, you had access from the side, and it could be that the beams were lowered alongside the invert. The area inside the tunnel was excavated and prepared, and then this beam was slid in horizontally. That may be the way it's done. Sometimes you have no access from the side, and these support beams have to be installed from within the tunnel. That can certainly be done. You have to remove the existing invert, you have to remove the rails or spread the rails to the point where you can introduce this member and an entire system of smaller members to resupport the existing rails. We really can't get into all of those details, and it's not necessary for the purpose of this class to really understand that process. It probably varies from structure to structure, but to understand the overall sense of what has to be done, you must introduce these horizontal members, and they must be supported on drilled-in piles or some other means that you are using on your project. And this is a good illustration of that technique. The new structural steel has been raised in place. These new white members are the permanent structure, but at this point the existing tunnel is still resting on the temporary supports. Getting the new steel in place is a challenge for sure. You finally get it as close as possible to where it's needed, and then you have to lift it in place. In a conventional operation, you have a crane that can pick the piece up and raise it to where it's needed. Working inside this kind of space, working under an existing structure, that's not possible. And the steel is generally lifted with a device which looks very much like a forklift. That's what's being used here. That can get the steel pretty much where it belongs, but for final adjustments to get it precisely where you need it to align the holes with the adjoining members, that has to be done with another kind of a tool. In this place, it looks like they're using a jack to make those final, very precise adjustments to set the steel in its final location. Here's a view of the rebar being placed for the permanent walls of this mezzanine space. The white sheet that you see behind the rebar is the waterproofing membrane. I cannot overemphasize the need to install that membrane with the greatest of care. There may be other ways to do the waterproofing. In this case, they've selected a membrane which is installed and the concrete is placed up against it. That's certainly a very efficient way to proceed, but the membrane has to be done with extreme care and control and an inspection process which ensures that the seams are perfect. There are no holes which have been made accidentally through the membrane. It has to be watertight to begin with, and it has to rest against a very smooth surface. As you place the concrete, it will push against the membrane, and the membrane really cannot yield or stretch. So this is a complex operation which has to be done by experienced people and then independently inspected prior to placing the concrete. There is no room for mistakes or errors or omissions or carelessness, because you'll never see that membrane again. It's inaccessible and it needs to be as carefully done as possible.